you get 200 OK, then you know that there is some sort of device which talks SIP. And this is how it looks like. This is a very small demo of some code which simply sends an options message, and you can see that it just replies. So by making use of this method, we can just send lots of UDP packets at our fastest speed. We might lose some messages, but whoever, if we randomize IP addresses and so on, whoever understands SIP should, by RFC, respond to us. So say out of 10 or 100 messages, we get 4 responses, and we just show them to the end user. And it's not just about SIP. SIP is really easy to scan. Even IAX2, which is the protocol supported by Asterisk, the open source PBX, which I'll be talking about later. And then there's other protocols, which I'm currently working on. Skinny, CCP, which is over TCP, H223 and GCP, and many other protocols, which are also alternatives for voice over IP. And we can scan for those as well. So these are some ideas. You can scan different ranges, you can scan randomly, and you can use alternative ports, not just 50, 60. Some SIP software clients, they might listen on a different port. And we can use other methods other than options. But options tends to be the safest one. And we can also scan whole countries. So we can extract some IP address lists of different countries and get some statistics that way. This is another presentation, but it's something which can give interesting results. So let's see if the demo works. So what I did was I launched a random scan, and it's randomly scanning for just random IP addresses over the internet. And you immediately start getting these responses. I'm just doing this to prove that there are lots of SIP devices out there which will respond to your scans. And this is, you can see it immediately giving us results. So as we saw before, there are different headers, and one of the headers is the user agent, which would tell us what sort of server or endpoint it is. But there are some cases, there are various cases actually, where the user agent is not printed out. Maybe it's modified. In the case of open source software like Asterisk, a lot of people like to modify the user agent so that they feel safer. Well, there are various ways of fingerprinting messages. So if it's a request, there are various things that are generated uniquely. But in our case, we're talking about responses. So we're sending a request, and we're getting the response, and we want to find out if it's a well-known vendor or not. So let's look at one message. This would be a normal asterisk response to our scans. And let's say someone tries to change the user agent. There is one obvious giveaway, and it's the to tag, which is generated by the asterisk. And it starts with AS, and it's generated by this sort of code. So it's only asterisk and derived code that does this. So we can simply build up a list of regular expressions, for example, or some pattern matching, and run through it and find out if it's asterisk or not. Now I'm obviously building up this list, but this is not only this is not the only way to fingerprint SIP messages. You can look at the order of the headers. Different SIP stacks will have different orders. We can look at the case to protect against this, of course, unless you decide to rewrite the whole thing. And yeah, this is another feature in SIP Vicious, which I'm fixing right now. So I'm cleaning the code and changing some things, improving. But this is till now I only spoke about scanning. What else can we do? Something which is more interesting. So we can find out which extensions exist on the PBX. So we can find out if extension 100 exists on the PBX or not.